Welcome back, student, to part 3 of the substitution method. We have this question, which is definite integral. So we have the limit of integration. So it's a good practice to see how substitution will work in the definite integral case. Now, the big discussion, if you look at this question from the beginning, you will ask yourself, what should be my u? Now, there are many choices. Well, the first choice that could happen here is somebody will tell me that maybe I choose u to be 2x because it's an inner function inside the e. It's a good idea to think of this one. So let me follow it up and see where it will take us. So this is solution number 1, u equal 2x. And so du is just 2dx and dx equal du over 2. Now, if we do the substitution here in this case, we'll get ex over 1 plus e2x dx. Now, if we change everything into u, this will be e power u, this will be ex, and this will be du over 2. Now, I'm still having ex here, so I need to replace x with something with u, and that will be u over 2. But that doesn't lead me anywhere. Dead end. Because remember, when we do substitution, we should have reach an easy, simple integral from the list. But this is not getting me anywhere. So please ignore the solution. Will not be used. Not a good choice. Okay, not a good choice. So let me do another substitution. Let me write the question again here. And let us think about the other solution. So now the second one is maybe I take u to be e2x. Well, that is not a good solution because from the beginning, what is the derivative? It is 2e 2x. I don't care about the 2. Now, e2x, do we see it in the integral on the top? No, it's not there. So this one not gonna work. Now, I will change it a little bit to something else. Look what I will going to do here. Ex 1 plus ex2. Do you see that I haven't done any harm here? It's the same. Because if we have ex power 2, 2 and x will get multiplied together, we get back to x. And now I'm sure that if we use the substitution, u equal ex, this is a good one. Why it's a good one? Because the derivative is ex again, which is already here. So let me just go ahead and finish this question up. And that is dx equal ex du. Now, the next step is to write the limit of integration. So we have integral from 0 to ln square root of 3 ex 1 plus ex squared dx equal to integral. Now you have to tell me from where to where. I have to change from x to u, but this will be done in the next step. Ex in the top will stay ex at the top, plus 1 plus ex squared, this is just u squared, and this is du over ex. Clear cancellation? And now everything in terms of u. Now there is one thing we need also to substitute, which is the numbers. Now remember, x equal to 0. How much u will be? Now the only way to do this is you go back to this equation here, and instead of x you substitute 0. So I will substitute 0 here. I will get e power 0, which is 0. So I will start from u equal 1, because if I substitute 0 here, I will get 1. The next one, you substitute ln square root of 3. Ln and e will get cancelled, so we get square root of 3. Do you have any question? If you have a question, please let me know in the discussion. Now the next question, I think it's fairly easy to continue. 1 over 1 plus u squared. This is just tan inverse of u. Integral from 1 to square root of 3. And then you know how to finish this up by the final substitution. Now, the last page in this section is how we can do things faster, because in Calculus 2, you know substitution method, but you need just to be a little bit faster. You don't need to do the whole steps of substitution method if we have it in this case. For example, if you look at the first question. Now, if we don't have a 3 here, this will be just ln x plus 7. Now, what will be the effect of a 3 if we use the substitution? If I call this one u, the only effect is I will divide by 3. So I'll get just 1 over 3 ln 3x plus 7. Now, the second one is we have x cubed with x squared. Now this is fairly easy, because all what you need is the derivative of x cubed. It will be 3x squared. So if we use the substitution, I will divide by 3. And then integral of sine will be cosine x cubed. But there is a minus because it's a negative cosine. Now if you don't believe me, do the steps, you will reach this one. With the time, with the experience, you will be able to do it faster. I'm leaving this one for you to try it yourself or do it yourself. Just try to be faster whenever you can. If you can't be fast, that's fine. Do the steps of the substitution. Thank you very much for watching section 5.5. Next section will be 6.1.